Hello everyone, I am Sakshi Tambe from MIT Academy of Engineering R&D, Department Computer Engineering, Division TY Tech A. In exploratory data analytics, now we will see the topic optimization of the loss function and best fit line using gradient descent. So, introduction to regression. So, what is regression? Regression is a fundamental supervised learning technique that models the relationship between features and a continuous output variable. The goal is to find the best fitting line or curve that minimizes prediction error. So here we will use one input variable with independent variable, feature or predictor variable, that is X, and second one is output dependent variable, target or response variable, it is Y. So this is a regression equation. The linear equation represents the relationship between variable, that is y is equals to mx plus c. Here y is the predicted output value, m is the slope, x is the independent variable, and c is the y-intercept. By using this regression equation, we can solve the example like predicting a student marks based on a hours study. So next one is the best fit line. So now we understand what is meant by the best fit line. The best fit line shows the trend or relationship between the input and output data. And this best fit line tries to close possible to all the data points. Means best fit line tries to cover the all data points. That is the y value that is come from the input variable x. Then the difference between actual and predicted value is called an error or residuals. So our aim is to make this error or residuals as small as possible. So the best fit line is one of that minimizes the total error across the all the point. So here we consider one example like a predicting student mark based on the hour study. Uh, some some students study 1, 2, 3, 4 hours. Their marks increases roughly in a straight line pattern. Here we see the mark increases in a straight line. This is the best fit line, shows how mark generally rise with the study hours. So in this graph, there is a straight line, that is the best fit line that covers the all the points. Now we will understand the what is the loss function. So loss function measures how well our regression model fits the training data. It quantifies the error between predicted and actual value. The goal is to minimize the error. So there is a formula. Generally we use the mean square error for linear regression. So there is a formula. Here is the formula of the mean square error. In this formula, y of I is equals to actual value, mx plus c is the predicted value, and is the number of the data points. And here our goal is to minimize the value of j in bracket m comma c. Next we will see the optimization. So what is optimization? Optimization means finding the best possible solution from all the possible options. In regression, it means finding the value of slope m and intercept c that makes the loss, that is error, minimum. It helps to model learn pattern from data efficiently. So goal of the optimization is to minimize the loss function, that is j m comma c. Now we see gradient descent. So gradient descent is an algorithm to minimize the loss function. It adjusts the m and c, that is slope and y-intercept, step by step in the direction that reduces error. Work by moving downhill along the cost function curve. There is a formula we use, that is new value is equals to old value minus alpha multiply gradient. So here alpha refer as the learning rate. Gradient descent equation. These are the gradient descent equation. M new is equals to m old minus alpha derivative of j with respect to m, and c new is equals to c old minus alpha derivative of j with respect to c. That is, here we find the new value of the m and c by using the old old slope and y-intercept. Then we will find the gradient, that is the partial derivative of j with respect to m and partial derivative of j with respect to c. This process repeat until the loss become the almost minimum. So here are the step by step how the gradient descent work. This algorithm follows an iterative process to minimize loss and find optimal parameters. So first is the initialize parameter. Start with a random value for slope m and intercept c. Here we choose some random value of the m and c. Next one is calculate gradient. So here we calculate the derivative of the loss function with respect to parameter. That is in last slide we see derivative of j with respect to m and c. Third one is update parameter, move parameter in the direction to gradient using learning rate. So learning rate means alpha. Here we use the alpha. Next one is repeat the process. Continuous iteration until the converge the propping criteria. So we continue all this process until the we get the minimum loss. Next one, here we solve the one example. Example is us predicting student marks. Example, our study versus mark score. Here we see the table. In this table, how many marks scored by the student and how many hours student did the study. So there is a 1, 2, 3, 4 and the marks scored by the respective student is a 20, 40, 60 and 80. So first step is initialize parameters. So let's start with the random value that is m and c. At the initial we take the value of m and c is equals to 0 and learning rate alpha is equal to 0.01. In step 2 define the loss function. We use the mean square error formula that is j m comma c is equals to 1 upon n summation of y of I minus mx I plus c whole bracket square. We use this formula and then step 3 gradient descent update rule. So m new is equals to m old minus alpha derivative of j with respect to m. From which we get the new m value from the old m value that is old slope. Next one is C new, that is C new is equals to C old minus alpha uh, derivative of j with respect to C. Here we get the new value of the y-intercept where we in this formula we use that is a derivative of j upon derivative of m. Here is the formula of here in next lecture we will see the formula of this derivative of j with respect to m and c. Now step 4, perform few iterations. So in iteration 1, since at the starting we take the value of m and c is equals to 0 and prediction is equals to 0 for all the x. Now error in y minus predicted value that is equals to 20, 40, 60 and 80. Then we calculate the gradient. So we calculate the gradient and then we update the parameter. These are the all are the steps of the gradient. Next step 5, next iteration. Here prediction with m is equal to 0 and c is equal to 1. We get the 11, 21, 31 and 41. This reduces the loss and gradient gets smaller. This algorithm continues updating until loss becomes a minimal. After this iteration, the algorithm converts around m is equals to 20 and c is equals to 0. And the last step is final best fit line. Now we have to draw the best fit line that passes through the that tries to passes through the all the point. So here equation is y equals to 20x plus 0 means each additional hours of study increases the mark by 20 means if student do the study 1 hour more then the student mark increases by the 20. So the conclusion is graph shows the mark increases linearly with the study hours. If the study improves, then the performance will also increases. That is demonstrating this perfect best fit line from the graph. So this is a code of gradient descent. Gradient descent implementation for linear regression. So this is the code and the output of the code here mentioned. So this is a linear regression using gradient descent. Study our study versus mark score. and the best fit line that tries to passes from the all the points. So in conclusion, so basically gradient descent helps to find the best fit line by minimizing the loss function step by step. It adjusts the slope and intercept, that is m and c, until predictions are accurate as possible. This process is the core of optimization in minimal machine learning, enabling models to learn and improve efficiently. So we cover the topic, that is what is the loss function, what is meant by regression, what is meant by optimization, where we see the best fit line, and one example of the gradient descent, how gradient descent algorithm works, and how to solve example by gradient descent. So this is all about the gradient descent. So thank you.